pure darkness. But then someone said, switch on the lights. This video is about how LEDs and other light forms have started and how excellent they are. So let's have a look at how we went from halogen and incandescent to LED technology. Thanks, Vic.
Cool.
Oh. In the dark with you again. Let's talk about incandescence. We have the incandescent bulb lighting me. So, how does an incandescent bulb work? So pretty much you get an you get electricity and you put it into it and it goes through a thin wire in a vacuum, and that wire goes and produces heat. Yeah, it doesn't produce light. And then that heat makes the wire glow in the vacuum. And then the vacuum's like, oh dude, this is cool. And then it starts like, yeah, heat, and then the light comes out and hits me. They're very inefficient because like, this is like, can you see me? I don't know. But it's running at 240 volts. And if there was a direct short over them, which I'm guessing it is, about 40 amps. That's a lot. Okay, let's move on to fluorescents.
What's this? It's post-production, Stephen. And I'm here to talk to you about why it was kind of inefficient. You see, you had to convert the energy to heat, so you would take the electromagnetic energy, and that would go into the bulb, and it will produce heat by heating up that wire, because that's how it works. And then that heat would kind of heat up, and then it would glow in a vacuum. So yeah, that's kind of why it works, because it can't really dissipate heat very well in a vacuum, so the wire heats up very, very fast. Yes.
Fluorescent bulbs, everybody. So this is probably what you've got on your roof. In fact, that's what I'm using right now. So the light's coming from a different angle. It's probably the one that's lit me up the best, but that's because like it's less efficient than LEDs. I'm just going to move the chair quickly. It's less efficient than light-emitting diodes, but there's a lot more electricity going into it. So what this does is it gets a tube of gas. That gas is known as mercury vapor. So, if it cracks, be fucking careful. Mercury is one of those chemicals that makes you really stupid before you die. It's like lead. Which is kind of funny because I assembled the LEDs with lead. Okay. How do these work? So pretty much you get a current and you put it through a tube which has mercury vapor gas, and that excites the molecules and the electrons and the elements and shit, and then that produces photons and stuff, beaming it out at you. Kind of efficient, but the big problem is that it creates a toxic waste, and in that toxic waste what happens is it just, like, when it's done you got to throw it out, but you can't throw it out because you have to go through a very big waste management collection, guys. So, these are pretty good, I guess. I mean, they take a while to heat up though. Okay, so for the last thing, I'm just going to say that LEDs are better than these, like, yeah. Let's move on to light-emitting diodes. Time to close the video, but let's just list off one more technology. Light-emitting diodes. LEDs. You guys may be hearing about it in the news. They're the new awesome top current. They're trying to do all this stuff. Well, I mean, they were invented in the 70s, so they're not exactly new, but the better ones that are like better were invented in 2015, and they can like make pure white light, which is good. Okay, so how does an LED work? Well, it's a diode. So pretty much electricity comes in here. So this is the diode. Let's say this is a current of like an amp, and it's like a negative thing. Yeah, doesn't go through, doesn't go through. You can only go this way through it. So it's like, okay, this guy comes along, yeah, you can go right over, but this guy gets blocked. So when that happens, it goes to a semiconductor, and this particular semiconductor emits light, photons, awesome stuff, photon torpedoes, Mr. Worf, do all that stuff. Great. It runs at about half a milliamp of current, and you guys may be thinking, half a milliamp? Seriously, dude? That's nothing. It's probably brighter than the halogens. In fact, I'm going to bet that it was better than the incandescent. But there's a difference. As I said, that runs at half a milliamp. Those other ones run at amps. That one runs at 240 volts alternating current. And yes, I know that volts aren't current, amps are current. This, which is behind the camera for this one, like the halogens, runs at 12 volts. So, very big change right there. I believe LEDs are the future. Thank you for watching, everybody. Subscribe, like, do all that. I forgot. Holy shit, that was a bad idea. Oh.